Chemistry Part 2, Semester 4, Paper 1, Theoretical Organic Chemistry. In that unit 1, Physical Organic Chemistry. So the next point is Taft equation. What is the question on that point? The Taft equation is a structure and reactivity equation which correlated only the field effect. Explain. हा क्वेश्चन अशा प्रकारे क्वेश्चन येऊ शकतो त्याच्यावरती. त्याचा आन्सर काय येईल? The Taft equation is the linear free energy relationship used to study reaction mechanism and in the development of quantity structure activity relationship for organic compound. Then the Taft equation is the modified phase of Hammett equation and correlated field inductive resonance in Hammett as well as the steric and substituent effect of a substituent. That is equation can also use the log in bracket Ks divided by KCH3 is equal to rho star sigma star plus delta Es, where the log Ks and divided by KCH3 is the ratio of the rate of substituted to the reference reaction, where the sigma star and Es are the polar substituent constant and the steric substituent constant respectively, and the rho star and the delta are the sensitivity factor. Then the reference reaction chosen by the Taft was the hydrolysis of a methyl ester with a RC double bond ON3. This occurs through the two pathway as acid as well as the base catalyzed mechanism by the tetrahedral intermediate. Firstly, the ester molecule is reacted with OH. OH is directly attached to the carbonyl compound, carbonyl group. Okay. Then O minus and OH is transition state form. Then in the next step, OMe3 group is lost and formation of the acid group, and methanol is lost. In the second step, the ester group is taking an H plus condition is a fast condition, so the step is a protonation. Then again the attack of H2O from the carbonyl group into the carbonyl group, and then next step is a removing of a methanol and the formation of a acid. It's a simple reaction. Is the best catalyzed mechanism by the tetrahedral intermediate. The formation of the tetrahedral intermediate in this reaction is the first in this delta minus and OH delta minus. These are the tetrahedral intermediate, and in the second step is the H2O attached to the carbonyl group and formation of OH and H2O attached to the carbonyl group. These are the tetrahedral intermediate in this reaction. From this reaction, the polar substituent constant is a sigma star can be given by the sigma star is equal to 1 upon 2.48 rho star is log Ks divided by KCH3 B minus log Ks upon KCH3 A, where the 1 upon 2.48 is a factor including the sigma star value near the Hammett delta sigma value, and the log Ks upon KCH3B and log Ks upon KCH3A are the rate of base and acid catalyzed reaction respectively. As both the rate are the similar and the delta star value get dependent upon the field created by the substituent, and this is because the steric and resonance effect are similar over the aliphatic molecule of ester. In the case of a very large group like aromatic ring, etc., steric effect are not a constant and the resonance matter in the more extent, and hence the Taft equation is a structural reactivity equation which is correlated only the field effect for aliphatic ester only. sigma value is a presented this the include field and inductance resonance contribution for the substance. They do not give the influence of a steric effect. The Taft developed scale for the LEF, LFER to the study of influence of a steric effect on the substance on the various reaction. The parameter that affect the polar nature of field and induction. The substance is the sigma star and the steric parameter RS are the both defined. The reaction is a acid catalyzed hydrolysis of ester. The next point is the linear Hammett equation. What is the question in that point? The discuss and one example of where deviation from the linear Hammett plot help in a detection of a change in the mechanism. Firstly, the linear Hammett plot affected so the greatly by the change in the nature of the substituent on the compound under the study as well as the mechanism. The deviation in the linear plot is a consequence of a upward or a downward direction. The deviation in their linear plot is the best example of a concave downward deviation is the cyclodehydration of a 2-phenyl triphenyl methanols. 2-phenyl triaryl methanols. These are the reaction of a 2-phenyl triaryl methanols H plus condition. The removal of H2O molecule in the formation of the product. This mechanism of a Hammett plot for the summation of sigma, that is the sum of the sigma x and sigma z versus log cops k observation given by. Firstly, in this mechanism, the H2O is protonated by the H plus and the removal of H2O, then formation of the carbocation intermediate and attack to the aryl group into the carbon in the carbocation and the formation of the product. Okay, the intermediate is the formation of the carbocation. In this graph, the log K observation into the formation of the sigma plus and summation of the sigma y. In this there xz value is a OME. Then rho value is a plus 2.67 and the minus summation of sigma minus value is a rho minus 2.51 and the xz is a Me methyl group. The left half of the plot showing the positive and rho value and the right half the showing the negative value indicate that the decrease and increase the positive charge on the reaction center respectively. As the if the x and z is OME, then the step 3 is the intermediate gate stabilized by the conjugation and the step becomes the rate determining step, is the RBS step. In that see the reaction. The firstly formation of a carbocation is stabilized by the methyl group. As the substituent is a X and Z having the low electron donation for the conjugation from the half right makes it difficult to form a carbocation and step to become the RDS. And further lowering the electron donating to reaction center caused a decrease in the rate of reaction and the graph pulls and bends down and happens due to the change in the mechanism at the step 2 and 3 by the varying the substituent character and hence the deviation from the linearity of a Hammett equation and plot the indicate the change in the reaction mechanism. The next is which type of question arises in this topic. They explain the phenomenon shown by the p-substituted phenol containing electron withdrawing groups during their ionization and establish the structure reactivity relationship for such a compound. The rate of ionization greatly affected by the substituent present on the compound as well as the nature, and the substituent constant value, that is the sigma x value, is obtained gives the great impact about the compound structure activity relationship. And the rate of ionization of some compound depend upon the some substituent effect like inductive resonance, hyperconjugation, etc. And the ionization of p-substituted phenol can be is the reaction is present p-substituted phenol H2, the carbanion intermediate is formed. In this case, the carbanion intermediate formed is more stabilized by the electron withdrawing group present of the para position through the conjugation or resonance. These are the resonating structure of the p-substituted phenol. They are attached to the NO2 as a withdrawing group. As the strong electron withdrawing group get attached to the p position of a phenol, then the rate of ionization of phenol increases. The anionic intermediate form get the more stabilized by the delocalization, and thus the ionization equilibrium for the para-nitrophenol was moved towards the right in the anion pair, and this is the induced stability by such a substituent get increase the phenol strength as the acid. The sum substituent and the sigma x and sigma px value are given below. Substituent CO, methyl CnH2O, CHO, aldehyde and NO2 group. These are the sum value of this substituent. Is a sigma px, sigma minus px and sigma px value. Thank you.